one up here like this. Trying to get it out of the light. I don't know if it's going to work. Anyway, we're at 12.32. We started at 12.34 a couple hours ago. I love it, man. It's not even a deep cycle battery, and it's kind of functioning like one or better. Imagine what it would be if it was a deep cycle battery. That would be awesome. It might actually break the bank right there. I'm not even talking about money. I'm talking about it might actually work. Now this reading I don't understand. It's negative 0.944 AC volts. And it's the output of the SSG. And that's what we're using right now, SSG, without gen mode. I don't think the reading should be like that. But oh well. It just changed. So looks like it's going up. When the negative number gets smaller, that means it's going up, right? Yeah. I'm doing a little experiment here with my name and the name of the show here. I'm putting my name first and who I'm doing it with, and then the name of the show. So we'll see what happens. Alright, looks like we're going to drop from 12.32 to 12.31 really soon here. Yep, there it goes. Alright, let me explain the drive system, and we can tweak from there. We got a potentiometer for the resistance. We've got a 30 gauge trigger strand. And then we've got 730 turns of 20, and then parallel to that we have 720 turns of 22. And they're linked in series. But let me try to explain the difference between a single file coil that's 1460 turns, and a parallel tri-filer coil that's that long as well. It's the impression is different. The electromagnetic imprint is way different. But you know, the parallel it runs good so far. I don't have a single file coil in this particular gauge. Actually, I do. But for the SSG, you need a bifiler, or you need to. Well, I could try, but the trigger coil doesn't like being in the pole. So like if I just put the trigger coil on top of that coil and ran that trigger coil through the SSG, I think it would not work. That's my hypothesis. But that's because I've done it before. I think we're doing pretty good for the SSG. Let me see if it's in the shot. Whoops. Yeah, that battery right there. The 20 amp hour battery. Right here, same power supply. So, what's different about this one is I've linked the 20 and 22 in series parallel. So they're wound parallel at 730 turns. In series, the total length becomes, 400 or 1460. But it's like having parallel batteries. See what I'm trying to say? It never gets above 12 volts. Doesn't matter how many batteries you stack parallel, it's always going to be 12 volts. If you're working with 12 volts, you get what I'm saying? Like it's same with the coil. It's only going to be 730 in the imprint. Anyway, that's how I look at it. That's how I see it. That the parallel series is way different than having a single file coil the same length. It's way different. I'm not saying which one is better. I mean, if I could make a coil that size, single file, I don't even know. Well, man, now I'm thinking about maybe doing that. Gotta think of like a good trigger. I might even do a reed switch. That might work, right? I was working with a reed switch earlier today. I think I blew this one though. I'm not sure. But yeah, I mean, you don't want your wire to be too long, because then the 12 volt battery is not going to work. And it's a 12 volt system, so you don't want your wire to be too long. Well, I don't know, honestly. It's been a learning experience. But I don't think you want it to be too long, because, seriously, the longer it is at a thinner gauge, because I just had a 24 gauge coil about the same size that was a bifilar, so it just had one strand of 24 and one strand of 32 in it. But it was about the same size. It was slow. It was slow. Didn't matter what I did with the pot, it was just slow. There wasn't enough juice to make it go fast. And speaking of the pot, we could play with that a little bit if you guys want. Alright, I opened it up a little bit. We got 1/100th of a volt back. Actually, 2/100ths of a volt back. But even with that, it's gonna backlash. Oh, it went up again. 12.33. Oh. Put my foot right in my mouth, man. That is a beautiful sign when it goes up after it stopped going up. That's freaking awesome.
How much is it generating versus spinning?
Right now, I'd say it's about breaking even. It's about at unity right now. This is how much voltage is in the system. That's the only thing I'm monitoring right here. It's how much voltage is in the system currently. And we're monitoring that at the battery. So I'm monitoring the battery, and at 100th, it's at 12.33. and it was just at 12.30 when I turned the thing, the potentiometer. But as for moving these meters around, I'm not going to do that. This right here, this meter is hooked to the output of the SSG. And what comes out the end of the SSG is crisp DC. That's what we get. We're gonna break it, we're gonna make it really small though. It's actually coming out in kind of a square wave. Wow, I don't know what, scope that is, how, you know what I'm trying to say, like, wow, I'm looking for, what I'm looking for, I think 500 millivolts, 500 MV is what it's at right now, is what it's reading by. But yeah, it's generating about 500 millivolts.
Does it generate when the input's turned on?
There's no input on. It's running on the battery. So yeah, it's charging the same battery that it's running off of right now. This is a closed loop system.
Oh, it's a time machine, okay.
It's coming, moving right along. I like what I did. Okay, it's starting to go down again. And I knew that was going to happen. So it's at 12.33, but it takes like 12 to 15 minutes for a tenth, a hundredth of the volt to go down, for it to change it all. Now it's running on 12.33 volts input. That's what the input is, 12.33 volts. Now what's coming through the system to keep it at 12.33 isn't a lot. There's not a lot of energy at all. I don't think this is an accurate reading, but this is what it's hooked up to the output of the SSG. So that's what it is. Bless you. And this is a different circuit than I was using yesterday. Yesterday I was using SSG combo with gen mode. This doesn't have gen mode. This is the SSG without gen mode. Right, I'm going to choke it up a little more. I think it's all the way over. Yeah. So I'm going to turn it up a little bit. It's got to be about 100. It's a 1,000 ohm pot, but it's 3/4 of a turn. So you get 1,000 ohms, and all you got to do is to do that, and you've done it. It's done. So you got to be really gentle with that. What's that? What's up, Mike? We're trying a different setup here for the closed loop single battery charge thing. Closed loop. We're just gonna call it closed loop. That's it, man. We're using the same battery. And I thought this couldn't happen. And in some instances, it won't let it work. But this is one of the things it'll do this. It'll do this one, and I like that. I tried doing it with just the 20, and it would keep setting off the sparks, and it wouldn't work. I don't know why. It's probably because the resistance was wrong. So far all I managed to do by changing the resistance is elongate. We haven't actually started to get, we're close though. I think I need a better pot. It is a 25 watt pot though, so I mean it's not a piece of crap. Could have a little bit more lines in it. It's an analog. An analog pot. We're down. It's going down. Okay. Of course it's going down. But, I mean, it's exciting when it goes up for a little bit and then it goes back down. Oh, it's going up. Oh, we're happy. We're happy. You saw that. Oh, if you didn't see it, it went from 12.32 to 12.33. Like, well after I put the pot down. So it's going in the right direction. At least, no. Okay, now it's going down. Or is it going up? I don't know. I don't know right now. It's in the flux. That area where it just goes between the two. I think it's going down though, for sure. Alright. I was playing with a reed switch earlier today, and my God, it is like such a different experience than using my switch. But with these coils that I'm using, they burn out really easily. And if I put a resistor on the path, they don't work at all. So awesome. The force of the magnetism made the, stopped it and made it go the other way. That's awesome. Kind of wanted to back it up a little bit. This is this here. What I'm doing it'll work. Uh, 12.32. It'll be there for a while.
Current RPM.
Oh, on the big one or this one? Either one of them, I guess. I'm not sure. I'm missing something. There it is. Yay, I'm not missing it anymore. Seeing if I can even get a reading on this one. Yeah, 241 on the big one, 236. Maybe 71, I got 71. I don't have a good tack strip on the big one. I do have one on this one. Maybe 805, 705, 702, 705. I don't really have a good tack strip on either one of these, but if you had to ask me, I'd say this is going about 700-800, maybe more. 805. CNN will say 28,000, 16,000. So there's duct tape on that, and that's probably what's screwing it up. But oh well. I'd rather not have my magnets fly out. But let me think here. What can I do to fix that problem? I have tinfoil, but I don't want to. Do I want to stop it? Put it on there? I don't know. And I can put some on this one too. It's picking up speed. But right now, I can tell you that it's at max RPM. Doesn't matter what I do with this pot, it's only going to slow down from here. Well, let me check that real quick. Make sure it's all the way over. Yeah, this is it. This is max cube right here for the system.
Yanni is in the house.
What's up, Yanni? So I think this is pretty close. And we're going by the battery voltage. Because in my opinion, that's all you really need to monitor. And if you can get it to the 1,000, That's where you really want it. And this is really all you have to monitor is the battery. Because the output of the SSG, all the output is going back into the battery. Okay? The same battery that it's coming out of. So why would you monitor anything else? I mean, honestly, you can tell just from that whether you're doing it right or whether you need to adjust it and which way to adjust it. Of course, you know which way you're going to have to adjust it. Right now, it's max adjust, so this is bust. This isn't going to get any better. I mean, for it being a closed loop, perpetual system, I like it anyway, man. It does wonders. It's great, but that's going to say 12.31 eventually. And it's okay. I'm going to make it do it right now. I'm going to put some resistance on the pot here. The wheel's going to slow down. But now we do have resistance. It isn't all the way off. And there it goes. There's a little bit more. I put a little bit more on there. Let me look and see how much we got on there right now. I'd say this is about 150 ohms right here. And and here it says we're making negative voltage. That I don't even know why it's doing that. But I know for a fact that the battery would be going down way faster than this if the output wasn't being accepted by the battery. It's almost running like it's hooked up to an alternator, but it isn't. No, it's not. Sounds like a great idea, but I don't even think that would work. Not to be run constantly, it won't work. You gotta have that break. Part of your system has to be, part of your timeline has to be that the system is completely cut off for a segment of whatever you're doing, whatever relay or whatever you're doing. You gotta have that break period for everything to recoup or dissipate. Then you get a really accurate reading. You get an accurate idea of how much is being generated and how much isn't. Because when I turn this off, if I unclip this right now, that's going to go up. That 12.31 will go up to like 12.36. Alright, so that was very short period and it's because of the pot. Having any resistance on this thing is a bad idea. So I'm going to turn it down all the way. Look, it went back up to 12.32 when you took the resistance out naturally. But I've had a couple of systems, not every system, where when you gotta and let's just go to the middle of the pot, Okay, let's just turn it all the way to the middle. Okay, we're down to 12.27, 12.26. We're a little bit over, we're like 600 ohms. 12.26, we're leveling out, like 600. But the RPMs, huh?
Brian said, thought about carrier voltage in the coils to lessen back EMF, working almost like a gear.
Maybe I've done that before, I don't know, I've never heard it explained that way. But I do know that this is missing, the negative spike is not being utilized in the system. The SSG has got just one diode in it, and it's a forward diode, there's no backward diode in the system. So the negative aspect of the system isn't being utilized. At least that's, you know, what I gather from it. It runs pretty good for SSG, you know, I think for having it be without that, it's running pretty smooth. And we can get it going pretty quick with the other diode in there. I think it runs a little bit higher though, the expense. But we could swap those circuits real quick. I like the gen mode. I like gen mode. Now we have options here. If I switch to the other circuit, we can hook up the 22 strand by itself, we can hook up the 20 gauge by itself, or we can hook up just two strands together like they are now. So we have options. Why don't we make a poll? To find out how we want to hook it up, the tri-filer. Alright, so I'll do it one at a time, okay?
Alright, so what kind of options should I put on the phone?
Okay, option number 1, 20 gauge.
Okay.
Option number 2, 22 gauge.
That's AWG?
AWG. And then option number 3, 20 and 22. We can, that's all we're gonna do for just the 3 options.
And what's the question again?
The question is gonna be, well, how do we want to hook up our drive for the SSG gen mode? and then encourage people to ask questions. If it's all right. Is it good?
Well,
I'll look.
just set a poll.
Nice. Okay, yeah, I see it. So it's going up now. You can't decide whether it wants to go up or down. It's going up now. I like that. I like it when it goes up. I keep on forgetting to put this in here. Wow, it looks like it's going a little faster now. Maybe around 1,000. Maybe not though. I don't know. I can't really tell. I always hated that about this setup is because the aluminum in the tin foil gets in the way of a good reading. The aluminum in the duct tape. My bad. That didn't make any sense.
We got it's a race, but we got 22 gauge.
22 gauge. All right. What's the race? For 20 gauge?
No, for both or 22.
Okay. All right. I like it. Because I think with both, we're actually, and this is what I was talking about them being in parallel. I don't think we're going to get any more like stronger spikes. The spikes aren't going to get any stronger by adding the length. What's going to happen is you're going to get two spikes, and they're going to be different, and they're going to be the same size on the oscilloscope. Because that's just the way I see it.
Alright, Brian's on Brian's like a gear comment.
Yeah?
He said idea would be to lessen or counter the back EMF effect with a constant electric flow through the circuit.
I hear ya.
Pulses would still generate a stronger EMF field, and the backflow would be less pronounced.
Yes. That sounds actually pretty cool. How would you go about doing that? Is that what it's like when you have a broken transistor? Like when you have that hiss or that hum? No, that can't be right. Go ahead and explain it a little further. It sounds interesting. So when this decides which way it's going to go, either to 31 or 33, if it goes to 33, I'm going to jump. I'm going to flip it. I'm going to do a flip right here on the camera pad. I'm going to jump. But I know which way it's going. I don't have to kid myself.
You don't got to crowd jokes.
I'm not joking.
He's like, I don't got to kid it.
We were close though. We were really close to something. And then if you had, what I'm saying, the difference is a single file coil that's the same length will have more on the same, be longer on the same path. You know, the winding would be totally different. The imprint would be totally freaking different. Just that's why I like single file coils. Like So I think I might have to make a better switch here. I mean, it works pretty okay, but the winding around the screw needs to be tighter. Jake, no. No, Jake. Wanna go out? There you go, buddy. Oh yeah, I hit a sweet spot over here, man. That's awesome.
And it's been,
Heck yeah, wow. Good for me. 12.32. It can't make up its mind. That's great, man. That is, let me go through the system. You got the double-stranded drive. You got the SSG without gen mode. You got the 30 gauge trigger strand. You got the potentiometer of 1,000 ohms. You got this AC/DC cat bank. So if you come AC or whatever comes in, it can come in DC. If it's DC coming in, it just flows right through. If it's AC, it gets rectified. There's 4 bridge rectifiers right in the middle here. And that's awesome. So it comes out the other end DC, like crisp, pure, straight line DC on this side of it. Because you know, when we zoomed in on the line with the oscilloscope, you saw how it turned into like a square wave and it had a bumping. None of that over here. None of that.
alright. Like I said, you would need your baseline pulse current and another current at about 33% of that amount that is always circulating throughout the circuit. Running both currents through the current circuit.
So you're basically telling me I need the 12 volt battery and say another 12 volt battery from a different input? I don't, but parallel. Because we're only going to work with 12 volts whatever we do. So we got the one that's doing all the power, and you said 33%?
Yeah, so that'd be like 4 volts.
4 volts. No, we'll do 3 volts.
And that,
Or we'll have to use a power supply. We could use a lithium ion battery if we do 3 volts.
okay.
We can do a power supply if we do 4. Probably do that right now. I just don't know how to do it. Like where to input it at. Just same input factor on the SSG. I mean, that doesn't sound like it would work at all. But like if I can find out how to hook that up, I'll put 4 volts into it right now. And then you're saying that that'll help it spin, basically, when you go faster.
You could use 2 outputs from the same battery with the regulator output.
No, I don't have any more room to clip anything else to my battery. So I'm not worried about using an extra power source in this experiment. I don't want to have to buy anything, so let's keep all the parts that, you know, I don't have a regulator. I apologize. I probably should have one. And if there's a different, maybe I do and it's called something else. Maybe we can go through the list of names, people call stuff, maybe we could find out if I have one of these things or not.
William is in the house.
What's up, William? We're trying to put an undertow of current. Maybe it'll be flowing in the same direction, but like about 4 volts on this thing. I don't know how to. I like what's going on over here though. This is whipping. This is nice. It's going under 100 milliamps. So about 70, 60 milliamps. Great, man. It's freaking awesome. But that's a single line series circuit. It's the simplest pulse motor circuit you can do. You got your switch, you got your coil, you got your power supply. That little triangle right there, you put it up against the rotor and it's going to spin. And yeah, it's a triangle. Have you ever tried to make a square out of 3 points? But I mean, you can do it. You can do it. You can do it. You can. I don't know how you do it, but I'm sure there's somebody out there that will do it. Absolutely.
Morgan says this is awesome.
Thanks, Morgan. Woo! So we're losing our 100th volt from like the beginning. I'm not sure what we started at, but I know it's around 12.33. We're now at 12.31. And I've messed with the pot here to try and, but I turn the pot even a little bit. This voltage number is going to go down. That's not what we want. Okay, that's exactly the opposite of what we want. So it's all the way open right now. 0 resistance, or the minimal resistance of the pot. Okay? Turning a little bit this way. Goes down at 31. And the sound changed. I heard it slow down like a lot. And we're only at 50 ohms.
What are we trying with the vertical?
With the vertical one, this is a closed loop system. So we got one battery using for charge and one battery, the same battery used to run. And we're doing pretty good.
Is this the B word?
What's the B word?
B word SSG?
No, this is K Energy.Store SSG.
Bendini?
Yeah, Bedini.
Or Bendini?
Bedini.
What does that mean?
So we're going to leave a little bit of resistance on there.
And then Morgan asked what kind of setup is
It's a Bedini SSG closed loop system. And that's it. That's what it is. I built it, so that's what it is. Let me think.
Tech Frank says, yay, I found the channel again. Like and subscribe.
Awesome. Awesome. That's cool. I know there's like very little substance out there these days. But it's all good.
It's all AI now.
Right. But for the substance that is out there, I gotta double down on my appreciation. I mean, the lack of substance I appreciate too. But, you know, people that actually like to have a conversation about what's going on here, I appreciate you double down. Absolutely, man. It's great. So the one in the back is the simplest pulse motor you can make. It's got a switch, it's got a coil, it's got a power supply, and it's got the rotor. And that's it. That's all you need to make a basic pulse motor. This one here is a little bit more complicated. So we have the potentiometer, which is 1,000 ohms. It's working okay right now. It works and it doesn't work, but right now it's working okay. We got the coil with the 20 gauge strand, the 22 gauge strand, and a 30 gauge trigger coil. Alright, we're going to let it redo. We're going to switch the circuits now.
Morgan says, what's the PPS rate? Is that pulses per second?
Pulse per second?
You mean RPM?
Well, it depends on the rotor, actually. This one has 3 magnets in it. So every revolution you're going to get 3 pulses. And that one over there is 9. So every revolution you're going to get 9 pulses.
Correct.
Alright, so let me...
What are you using to generate the pulse?
Trigger strand and the magnets. So every time the magnet passes the coil, it triggers the transistor through the trigger strand. And the one in the back, I'm using a homemade reed switch. One that I made. It's with a screw and a piece of copper.
Yeah, pulse per second. So we'd have to take the RPM and number of magnets.
Yeah, I agree. That's really interesting. I never even thought of figuring out pulses per second, but it's going to be pretty easy with the math that we already have. I don't know if we're actually going to do that, but we're going to try maybe. And we don't have a good way to read the RPMs right now. I think we're going to do just the 22 gauge strand. Now the clips come
Are you an electrician by trade?
out. No. Well, I don't mess with anything over 12 volts. I guess I have managed to get some way, or shape, form, an appendage in a light socket before myself too. I know what it feels like to get this chipped out of you, man. It sucks.
Ron's big idea says good evening.
Good evening. Welcome to Pulse Motor Bros.
multi-core for the pennies. So Johnny.
Multi-core. Oh, yeah. Don't have a core, multi-core that'll fit. That would be nice.
Brian said he's just thinking out loud on that gear idea.
Okay. Well, that's cool, man. If we want to figure out how that's going to work, it is a kind of a good idea. And I can see where it can be useful to negate lens effect and stuff like that. Or will it make it more lensy? I don't know. Honestly. It is pretty interesting. Alright, so this is the SSG with gen mode. We're going to hook that up. See if we can't get it hooked up. Before the wheel stops spinning. And we got this one working transistor, so I hope we don't fry it while changing all this stuff.
Headlights.
Nice. Right. Hope I get this right. I'm so blind.
Thank you, Ron. Ron likes
Thanks, Ron.
Ron's we got this.
Alright, so the four main wires are in. We gotta put the pot in. Let me get that real quick. Then it's like trying to make everything connect together when it doesn't. We're not gonna make it in time. This is such a mess. Oh man, okay. Come on, man. And here we go. It's just the wires, all the extra clips and stuff. Like I said, trying to put things together that aren't supposed to go together. You need to find a creative way to bridge that gap. And the moment of truth. Near. Right now. Okay, here we go. Get it spinning a little bit. This is why I wanted to have it.
How long have you been working with that agent?
2, maybe a year and a half. We got a nice dip in the juice already. 1235. Maybe 1234. I'm going to choke it up a little bit, get it to like 230, because that's what I normally run stuff on.
We got us an engineer.
Awesome. Oh, that's me? All right. I mean, maybe if they ended up like teaching it for free, I go and get my license or something. But I already got 70 grand in student loans, so I'm not interested in doing any more loans right now.
You have an inline fuse.
An inline fuse. I think I do, I just don't know how to set it up. So I'm going to ask real quick, this end isn't stripped. Should I strip this end and then just plug it in the line? Use a clip, just like clip it in there. Or use one of these clips even. But it's not hooked up. Yes, I have one, but it's not hooked up. Alright, I think it just got interesting with the potentiometer.
Do you measure or try different pulses with on time versus off time?
Only when I'm using that signal generator do I mess around with the pulse. If not, it goes how it goes. Only when I'm messing with the signal generator do I tell it. If it's not a signal generator, it's telling me. Basically.
Okay.
And that's with the arbitrary form waveform generator. You know, it's got to have both. Some of these little ones that come in the multimeter settings, you know, they don't have the arbitrary waveforms. But I'm talking PWMs. Like, some of them do, some of them don't. But I'm almost certain that the waveform is the pulse. I don't see, because I have lots of PWMs lying all over the place. I don't know where any of them are right now, but as far as I know, they do pretty much the same thing, except allow you to change the waveform. Have multiple arbitrary waveforms. They just have sine waves.
Alright, we got a question from the Dirt Bike.
What's up?
Says, I don't know much about pulse motors. What voltage do they run?
They run on various voltages. They can scale up, but normally you want to have the same voltage going in to the voltage going out. So like if you're going to charge a battery with a battery, or you're going to use batteries, you want all your batteries to be the same voltage on either side of your circuit. And that's pretty much it. So this is a 12 volt system. 12 volt battery.
What's the lowest voltage you're going to use?
Lowest voltage I've used is 0.18 of a volt.
Wow. Square wave generators?
Square wave, I can do a square wave. I'm not sure what you mean though. I mean, probably it comes out a little chopped up, but none of that means anything right now. What waves being generated from this doesn't mean anything. The only thing that matters is this number right here. 12.31.
So, Dirt Bike said, dang, that's awesome to get one to run on such low voltage.
I know, man. I was thrilled. I was like, hell yeah. And I'll show you the rotor that I actually got to work on.
ICV, what is this used for?
Right here.
Morgan said you should try different waveforms like sine wave versus sawtooth.
It's not called sawtooth though, it's called triangle. But yeah, I know which one you're talking about. It looks like a sawtooth, but when I go through it, I don't have a sawtooth, quote unquote, called sawtooth wave. I have a triangle wave though.
That's cool motor. probably distorted from the inductance.
So I've been alerted to the fact that there might be a delay. So if there is, I apologize. If not, we're going to keep rolling. So running just the 22 gauge strand is a little expensive cost-wise. So I think getting the extra kick of BEMF, even though it's a lower spike, or mid-level spike, whatever we want to call it, getting two of them is definitely better. And it's probably the SSG gen mode that is making
What's
the
coil
difference here.
pressure hammered?
You're talking the inductance.
I think so.
It's low. It's really low. Like micro henries. It's not much at all.
Yeah,
I think the reason that the wheel is spinning so well is because it's got ceramic bearings. So the sweet spot for this coil is way different than the sweet spot for the series coil. It's way different. That's pretty much it right there. And I want to see how much that is actually. I think I hooked the red and the green clip in backwards, so maybe 200 ohms, 150 ohms. It's either that or it's 750 ohms, which I don't think it is. Could be though. I wish it was more clear. I wish you were more clear with what you were trying to say. It's not clear, man. It's clear as mud. Not clear. So I just go by when it stops going up or down. I just leave it there.
Can you scale that up or down?
Scale this? No, you have to build an entirely new motor to scale anything up or down. But you can make this bigger. You can make this 8-inch disc into a 12-inch disc. You can make the magnets from the 1-inch cubes into 40 millimeter magnets. That's how you scale it up. You make it bigger, or you scale it down and make it smaller. Same with the voltage. You don't want to then make a huge thing and then try to run it on 12 volts. You make a fat coil, you're going to need to put more voltage into it. You know what I'm saying? So like if you make a coil, if I made that into a single file coil of 20 gauge, now let's see, that's 730 times 3, so that's 2190, 2,190 turns. And that might actually be a pretty good coil. But I'm guaranteeing that with that, you're going to have to put in at least 18 to 20 volts just to get it started. Yeah, you scale up, you gotta scale the voltage up too. It's like pretty simple. But can I like snap my fingers and scale this up? No, I can't do that.
Anyways, the price is right for you.
Yeah, the price is right. It's happening right here. And the Wheel of Fortune's over here.
Blue 20 gauge is took the lead.
Oh, all right. All right. So it's after the fact though, but all right.
Yeah.
Definitely. Let's try it. Let's do it.
It's after the fact. I left it up, but they kept doing it. Thank you all.
I really appreciate you guys chiming in though, but you see it starting to slow down maybe even a little bit.
17 volts.
Cool. And the give a little rebound with the battery real quick. See, this is that off phase that I'm talking about, where it's like totally just not even flowing. The battery juice goes up. And you need that little uppage to go back down when you come around your next cycle.
Up it is.
Alright, not bad. I got excited and I started unscrewing everything. I wish my screwdriver would just pop up out of the snow like a daisy. Oh, I said that wrong. It's the middle of summer and I'm talking about snow.
No.
I want my dang screwdriver.
We're gonna have to
Buy a new one.
sure got this place apart.
I threw it out, I'm pretty sure.
Oh, man, sorry.
Yeah, I mean, I don't know that for a fact, but I'm pretty sure.
Go laying in a box or something.
No, it was in my hand with a bunch of trash, and I just threw it in there.
That's even worse.
Yeah, when you do it yourself.
Yeah. I've been there.
Alright, now this, I don't know if this is going to work at all, guys. Oh. Dang screwdriver. Oh. Alright, then we'll hook up the pot. Potentiometer. Alright, pot's hooked up.
2,000 views.
Awesome. Alright. See, this is it right here. .20 gauge strand. See, and this prevents any flashing, so the battery doesn't spark as much as it did before. And there's no short circuiting going on. Now, another thing that we can do, maybe, is raise the coil up another centimeter or so. So that's 730 turns of 20 gauge at 12.3 in. Does it look any better? I think it looks better. But I think we're going to end up using both strands because it's going to give us the extra inductance. I mean, the inductance value is not going to go as high as it would, like I said, with a single file coil. But it will be weird. It's hard for me to like see it in my head exactly what will happen, but it's like,
How many light bulbs can you put in that?
At least one. And then we have two, sometimes we have four going at a time. It's pretty awesome.
Yeah.
We got a tri-filer coil and an output to do this one. We can put two on this motor right here. Probably one on the other motor right now, so that's three. But we could always hook up the other SSG right there to the other motor instead of running it on the reed switch. And I'll tell you what, man, that thing will whip. If you think it's going slow now, that's because it is. As soon as I find my box of hangers, I can make some of those cores that we need so desperately, the multi-core. See, I already have a box of hangers made out of some sort of steel, so I'm not going to buy low carbon rods from Amazon because that's money I don't need to spend, really. How's it going, man? You alright?
Yeah.
Awesome. Maybe I should hook up that SSG.
The idea here is to see how efficient we can make it work.
The idea is to, yeah, pretty much, since the trend is that it's going to go down, to see how long we can make it last before it actually goes down. On the 100th scale, now if I had a meter that went to the 1,000, that we would get a way better idea what's going on right now. Alright, so I had a brilliant idea. Now I got an SSG circuit over here. That I can hook up to the big wheel over here. Oh yeah, my bad. We can't do that. I would love to do that. I really, really wanted to do that. But we only have one working transistor. So you can't naturally do two transistors.
No.
Uh, but I ordered some, so they'll be here tomorrow. And the other thing that I think might be cool is to run a dual drive. The same way we're running this. So each drive charges its own battery on the same system. And then it'll work because these are just 2 gauges apart, 20 and 22 gauge. And it'll increase the speed by not double, but just under double.
What kind of transistors are you using?
Oh, let me see what they're called. They're the Toshibas. I can't really see it. 250-200s, something like that. The last digits are 200. Here, I'll put it up here. Maybe you can see it better than I can. Not up there yet? I'll just
Just go up there.
oh wow. I think there's a dead zone in that corner, bro. Of my room. But phones don't work over there?
I think the phone's fine.
No, my phone doesn't work in that corner.
Because he already came in with the comment. Just came up.
No, I know the phone's good. I'm saying that corner's bad.
Alright. Said look up the data sheet for you one low infinite distance. Try some IRP 260 MOSFETs.
Yeah, these circuits that I'm using are designed for MOSFETs. They're not. But you know, I could try to use a MOSFET with the same pin out and see what happens.
You're using IGP2S.
I don't think I'm using NPNs, whatever kind of NPN they are, I don't know. I don't know, honestly, and they're not really that, you know, in depth where I get them from, so.
There's nothing to say, I'm just throwing ideas out.
Oh, you're good. You're good. I don't want to sound like I am sharp. I gotta put it out there, man. I'm pretty quick. And I really do want to try out some like MOSFETs myself, man, because they get much higher switching rate. They use superconductivity instead of, you know, what the other types of switches use. So I do want to get involved with that. I don't know if they'll work in the DSSG over here. But if they will, then heck yeah, man, I'd be dying, because I bet we could increase the RPMs on this by at least 2,000 if we started using MOSFETs. But for the height on this thing, it is right now about half an inch off the coil, and that's perfect to negate lens effect. So there's very little lens happening on the rotor right now. I mean, it's the appropriate amount for how far away it is from the coil, but that's a very little amount. Very little. So I don't know, there was a hypothesis put forward that the lens is actually where the electricity is generated. I don't know if that's true, because we're generating enough electricity here to prolong the life of 1/100th of a volt by, 15 to 20 minutes. And you guys know how fast this battery would be going down if I didn't have the output plugged back into the battery, right? Or do you want to see that? Is there anybody that wants to see that happen? I don't. So, I mean, that'd be like... So everybody knows that because the output is plugged back into the battery is dropping slower than it should for what it's spending. Right? Now what I could do, like might be able to retrofit this 9 magnet rotor over here, to spin on this wheel right here. Of course, I'd have to put a bunch of tape on it and make sure that the magnets didn't slide out of there. Putting it on its side like this. Because that would make it a 9 magnet rotor instead of 3. And that'll give us way different output and input or need. I think this will end up being power hungry though, but it is like a flywheel. This thing weighs like 4.5 pounds. 3.5 pounds. 4.5 with the toroid magnets.
Says dual beam circuit. Look it up. Have you looked at that?
The Joule Steve circuit. I've looked up, well, I'm trying to get my lightning thief circuit from Benefactor. So I've been a member of the channel for a while, so. Yeah, I've heard about the Joule Thief for years now, though I never really understood much about it because it's solid state. I don't really do a lot of solid state stuff. I get it though. I don't know exactly what it does, and I don't know. We have to see. I like a lot of my stuff to be automated. You know what I'm saying? That's why I stay away from the pot for so long, because you have to get in there and play with it. So I don't know. And it's cool when it works, but when it doesn't work, it's just you stand in there for 40 minutes playing with the thing, and it's just you're missing it every time. And it's like you got to reset it, and it's. But when you hit it, it's like, amen, brother, time to move on. But I can see how that would be another one of these things that I'd have to monitor if I have to do anything with it. Because I know the lightning thief has a button that you need to press. Yeah, man, that would be awesome to get my hands on one of those, especially when they're nice new packaging.
You're trying to manipulate the mechanical aspects to achieve different results.
Well, I manipulate the resistance for one. I experiment by adding and taking away the number of magnets that are on the rotor. So I got 9 there, I got 3 here, I got 2 down there, I got 12 over there, I got 12 down there, I got 9 right there. You know, I got all different kinds. The ones I stay away from is 8 and 10. So I don't do 8 and 10. At least not yet. I got 4. I had one with 5. I had one with 13. That was an amazing one.
Very cool.
But yeah, there are some variables in these experiments that you can manipulate. There are some that you can't, and they're called constants. Like the amount of ohms in your coil and your drive coil, you're not going to be able to change that no matter what you do. So that's a constant. And it's not a variable. You know, you gotta keep those things in mind, because anything that you can change, you should change it. But you shouldn't try and change something that you can't change, or waste any time thinking about it. Really.
Unless you change the entire coil.
Yeah. If you make a new coil, then you can compensate for whatever deficiency the other coil had. But I guarantee you that there's always a better coil.
Can you put magnets on an alternator pulley?
I don't know. I've never been inside a car. I wish I knew more about alternators, man, because I think I might want to like use one on one of these and see what happens. But I've heard that they really don't make a difference in how much energy you're going to generate. Which I don't know if that's true or not. That can't be right. You know, in my mind, because a car battery inside a car can go for like frickin' 20 years without ever needing to be charged. You know, because the alternator's got to take care of. All right, we are accepting donations. Okay, if you want me to use low carbon steel rods, well, you can either buy them for me and mail them to me, or you can donate on the channel and we can take care of it that way. But, you know, I haven't necessarily decided what I want to do with all this stuff. Because you know me, I don't really care. Like too much. Like it's not like I'm not banking on it and it's not banking on me kind of thing. It's like I'm just here dabbling in it. And I think it's pretty fun. It's pretty cool. I've spent, 3 years of my life altogether with the magnets and the electromagnets. Now I think what's really cool is what Old Man Builds is working on. Yeah, man, he's trying to make a bridge where there's a big ass gap. And this is going to be awesome if we can figure this out for an elongated period of time, for a substantial period of time. That will be a feat worth documenting. But it's got to be frustrating. It's got to be frustrating being on the frontier, man, being a pioneer, unearthing what's been buried, and trying to reverse engineer it without having, maybe the smarts or whatever that the predecessor had or has, or whatever's going on, be it political or any other. I don't know what the word is, but blah blah blah. That's all it is. It's just me venting a little bit, maybe. I think it's cool though, man. I mean, it's been at, in between 12.31 and 12.32 the entire time. I mean, I had to mess with the knob a little bit to get it back on track. That it's been at 20 gauge. So the 20 gauge is actually a really good strand to run this on. And it's accepting resistance and still spinning, which is awesome. Because every other strand or whatever, I would add resistance and it would slow down to the point where it actually stopped spinning.
Howdy, what's going on up here?
We got a vertical and a horizontal pulse motor. This one over here is a simple circuit. You got your switch, you got your coil, you got your power supply, and you got your rotor. Simple as it can be, right over here. And this one is a self actuating. I don't know what it is. It's a self-closed loop system. That's what it is. And there is a small bit of loss. Man. It's a very small amount of loss, but it's enough that if I left it running, it would die in like 3 days.
22 days back in the league.
Yeah, I know. They want to see me hop around. That's funny. But I think what we're going to do next is we're going to put the 20 gauge first, and then we're going to hook it in series to the 22 gauge, and then we're going to go from there.
Volts.
22.
Oh, yeah.
But as soon as I hook up the elongated strand, it's going to slow down again. If I hook up the 22 gauge, it's going to slow down again. So if you don't mind that, then we'll move on. If that is a big deal, then we'll just leave it the way it is.
Are you pulsing at 24 volts DC?
No, it's 12 volts, and it's coming from this battery on the side here. I'm just using those two batteries as a stand to keep it elevated above the coil, the wheel. But I was just thinking about using a system just set up just like this for a relay and using these two batteries in it. I gotta charge those. And that's gonna be probably a week or two from now. But yeah, that would be so clean cut and tidy and everything, and have a relay switches right here in the front and just bam. Be so clean, so cool. But this is clean and cool too, man. I mean, this battery on the side here, 20 amp hours. See, but right now, if I had another transistor, what I would do with it is I would hook up. See, and this is it, man. This is where it's kind of messy. This would be the trigger coil for it.
What's the pulse voltage? I'm trying to get caught up.
Pulse voltage? I have no idea what that means. What is the pulse voltage? Is it the DC voltage? I don't know. Actually, I think this might be a little too big. So I wouldn't be able to do that with the SSG circuit. SSG, I'm pretty sure, needs its own trigger. But I could run two 1, 2, 3 circuits, one on each strand. Hook them up to a power supply. Oh man, that would be so fun. You just, I don't know, really fun. So I dropped a core in this one over here, and the overall cost has gone down. Brilliant. See, the core is a lot more beneficial on the generator side than it is on the drive side, although there is a small benefit on the drive side of having a core as well. Alright, I got one other thing that I'd like to try or show you guys. Now this one right here is a 16 gauge drive. It's a bifilar coil with a 26 gauge trigger. It's a tiny little coil, man. And this thing, whew. But that again will be for another day because I'm gonna hook up a different wheel entirely for this. That is moving quite awesome. The sweet spot. So I'm thinking right now I'm gonna hook up my multimeter to the tri-fiber strand and see how much generated and energy is coming off the 22 gauge right now. Oh yeah. It's an AC coming off the tri-fiber strand and it's about 5.5 volts. Stable at 5. And 5.21 volt. So yeah, here's our 1,000 right here. And that's about how much voltage is because it's so steady. Like if it goes down at all, it's because the the voltage went down. It's basically because it's getting slower. That's awesome. So this is the tri-fiber strand. This is a 22 gauge strand that we were using as a drive earlier. Is now generating for us 5. Oh, we have to use a diode though. We have to use a diode off the strand. We can hook it to the end of this cat bank. Yes. I can see. Good day, man. Alright, well I guess we're gonna call it for tonight and I'll catch you all later. Thanks for coming by. I really appreciate it. I know.